It's your friendly math tutor, Miss C here, and today we are solving absolute value equations. So we have our equation to the left, and you're going to notice that I've written PEMDAS to the right. So this is an acronym that we use to walk through solving equations. It's tied to the order of operations, and because we are going to be moving across the equal sign, so I'm going to draw a line here to divide my equation into two sides, the left side and the right side. So I'm making sure that what I'm doing to one side, I'm also doing to the other. When we move things across equations, we work PEMDAS from left to right. So my ultimate goal is to get x by itself. But before we can do that, I'm going to be trying to get the absolute value of 2x plus 20 by itself. So let's get started using PEMDAS. So I'm working from right to left. We're working PEMDAS backwards. So I'm going to tackle any addition or subtraction that I can. And what I can do is I can subtract 18 from both sides. So when I do that, I'm left with negative 3 times the absolute value of 2x plus 20 on the left side. And on the right side, I have negative 12. Okay, now I'm going to go ahead and move to the next part of PEMDAS, and that says I should be doing any multiplication and division that I can. Remember, we can't do anything to what's inside the absolute value bars. It's like it's stuck there. So the only multiplication or division is this negative 3 right here. So we're going to divide that off of both sides. And when I do that, I get my absolute value and what's inside by itself. And then on this side, I get 4. So this is where we always want to stop with absolute value equations and do a quick check. Whatever the absolute value is has to equal a positive number, and that works here. So we're going to check that. If 4 was negative, we're done. There's no solution. So I think it's always a good idea to do a quick little mid check to make sure that we're on the right track. And now we are going to drop our absolute value bars, but to do that, we have to set up two equations. One where what's inside the absolute value bars could be positive 4, because the absolute value of 4 equals 4, and one where what's inside could equal negative 4, because what's inside of the absolute value bars could also equal negative 4, because the distance from 0 of 4 and negative 4 is both 4. So that's why. So let's go ahead and do that. So I'm going to set up my first equation, 2x plus 20 equals positive 4. And my second equation is going to be 2x plus 20 equals negative 4. And now I'm going to solve these using the order of operations. Once again, I'm doing any addition or subtraction, and then any multiplication or division. And I'm going to do that on the next side. So I am going to go ahead and subtract 20 from this side, and I'm left with 2x equals negative 24, divide by 2, and x equals negative 12. So when I come back up here, I'm going to check one of my answers just to make sure. I'm going to pick the negative 12 one. You should check both of your answers, but for our purposes, I'm just going to show you how to check your answer. So you're going to see I plugged one of my solutions in here. When I do that, this should be an absolute value bar, I end up with 2 times negative 12, that's negative 24, plus 20 is negative 4. So remember how we said what's inside the absolute value bar could be positive or negative? That's where that comes from. This becomes negative 3 times the absolute value of negative 4, which is 4, plus 18 equals 6. So we have negative 12 plus 18 equals 6. That's true. This is a solution. If you plug negative 8 in, you would get positive 6 out as well. All right, so that's how you solve that equation. Let's do another. All right, we're on to our second equation that we are going to solve. I'm going to write PEMDAS over here one more time as a reference, and we're going to move through this a little more quickly than we did the last equation. I'm going to go ahead and divide my equation into two sides. And we're going to start with addition and subtraction. Remember, we're trying to get x by itself, but first we're trying to get this absolute value part of the equation by itself. So we're going to get rid of the 9. Remember, we're making a 0 here. And what we do to one side, we do to the other. So that's why I added 9 to both sides. When we do that, we get 11. Okay, and now I need to get rid of the half because now we're to the multiplication and division part. Here's the deal. You can divide both sides by half, or you can multiply both sides by 2. I prefer to multiply because I don't like putting fractions into a calculator or trying to do them in my head. So you'll get the same answer regardless. So when I do that, this becomes a 1, and I'm left with absolute value of 4x minus 10 equals 11 times 2, which is 22. Also, 11 divided by half is 22. So you get the same thing. So good news, we're to the point where we're going to do our check. Is the absolute value equal to a positive number? Yes, it is. So now we're just going to go ahead and divide our equation into two separate equations. So we're going to say 4x minus 10 equals 22 and 4x minus 10 equals negative 22. Remember, you're going to have a value that could yield positive 22 in the absolute value bars and a value that could equal negative 22 in the absolute value bars. And that's why we have two equations. So we're just going to solve these. We're starting with addition and subtraction again. So I'm adding 10 to both sides. When I do that, I get 4x equals 32. I'm dividing by 4 to get x by itself, and we get x equals 8. All right, on this equation here, I'm going to add 10 again to both sides. We get 4x is left equals negative 12. Dividing by 4, x equals negative 3. Make sure you check your answers here. Sometimes I like to do these in my head. So I know that 4 times 8 is 32 minus 10 is 22. 22 times half is 11 minus 9 is 2. I could do the same thing with negative 3. 4 times negative 3 is negative 12. Minus 10 is negative 22. Absolute value of negative 22 is positive 22. And we're back to where we were. So this is correct. On to problem 3. Our last equation. Look at all those negatives. So let's go ahead and get started. Dividing my equation into two sides. I'm writing PEMDAS over here. Okay, so just as a guide, so remember, I'm trying to get the absolute value bars as an initial step on its own, and then I'll get x by itself. So to do that, I'm going to do any addition or subtraction. So I'm going to do the opposite of subtracting 7, which is adding 7 to both sides. When I do that, I end up with negative 5 times the absolute value of half x minus 3, all in the absolute value bars, equals negative 17 plus 7, which is negative 10. All right, now I am to the multiplication and division part of my PEMDAS, and I'm going to divide by negative 5. So make sure you divide by that negative. And I'm left with half x minus 3 in the absolute value bars equals positive 2. Remember, this is the point that we check. Do we see that what's in our absolute value bars equals a positive? We do, because remember, absolute value only equals positive values. So now we just set up our two equations. Half x minus 3 equals positive 2, and half x minus 3 equals negative 2. And we're going to go ahead and solve those. So I'm going to add 3 to both sides. When I do that, I get half x equals 5. Okay, like I told you before, I prefer to multiply instead of divide. So I'm multiplying by the reciprocal of half, which is the same thing as dividing by half. And when I do that, I get x equals 10. So that is one solution. I'm going to add 3 on this side. And when I do that, I get half of x equals positive 1. Okay, I'm going to multiply by 2 on both sides because half times 2 is 1. So 1x, or just x, equals 2. And these are my two solutions. I should double check by plugging these in that this is correct. I already showed you how to do that in the first problem, so you can go back and look at that. I already checked my answers, so these are correct. Thanks for solving absolute value equations with me. Till next time, remember, you've got this, and don't forget to subscribe.